Welcome to a lesson with Dr. Powell. Let's take a look at some ideas. Directly proportional, inversely proportional, jointly proportional. What do these things mean? They often happen in word problems and other situations, but how do we interpret them? Well, here, let's look at this first one. T is directly proportional to L squared. So think of the word proportional. That means like a percentage of or a fraction of. It's equal to a number times this guy, right? Like a decimal number. Well, any number can be thought of as a fraction or a percentage if you want. Let's just call that number K. So T is equal to some proportion of L squared. So T is equal to K times L squared. This might pop up sometimes. Now, how would you use it? Well, maybe perhaps this wording occurs somewhere in the word problem, and then maybe you also have an example given with some values. Like, let's suppose that when L is 2, that T is 20. Well, what does that mean? Well, if we throw these numbers in, 20 is equal to k times 2 squared. Notice that k is 5. So using the example values, we can find, for these guys, we can actually determine what this proportion is. So it's 5. So we have t is equal to 5 times L squared. And then oftentimes in the word problem, they might ask you something else. And maybe they want to know what L is or T is at some point. Maybe the question is, um, maybe even quite simply, when L is 3, what would T be? Well, just stick that 3 in there, and you see 5 times 3 squared. So 5 times 9 is 45. So T would be 45. So that's a way that we can use this wording in a word problem. Or word problems that you see like this. Um, First, have wording from which you write a formula. Next, they give you values that you can use to find k. And then last, they'll give you a situation where you get to use that k value that you found in order to solve for a certain variable given the values of other ones. Pretty much problems like this are of that nature. All right, what about h is inversely proportional to m? How would we interpret this in a sentence? Well, again, proportional, so we think some constant times. Inversely, that's actually multiplicatively inversely, meaning in the bottom of a denominator or a division even. Um, so like a 1 over m. So h is equal to a proportion of the reciprocal of m. See, this inverse kind of means like reciprocal of m. So h is directly proportional to the reciprocal of m. But instead of saying reciprocal, we just say inversely. That's what that wording means right there. And then you can solve for k if you had a value of h and m, and then you can use that maybe to answer a question. Okay, what about jointly proportional to a and b? This simply means that J is proportional or equal to some proportion, so K times um, the product of A and B. That's what this word meaning jointly means product in this case, A times B. Now, in all of these cases, see this K, it's called the constant of proportionality. Um, and it is possible that in a given situation, we might say something like this. T is directly proportional to um, A, but it's inversely proportional to the square root of B. Notice how I use two things here. So K is proportional to A, but inversely proportional to square root of b. And I said that all at once. So these proportions kind of keep everything in the playing field of multiplication and division. And this is what that would mean if you put it together um, here. So some constant of proportionality multiplied by a, but then divided by the square root of b. So directly proportional to b, but inversely proportional to the square root of b. So directly proportional to a and inversely proportional to the square root of b. Um, what about another instance? What if we had something like this? H is equal to k times, um, let's do c times d squared all over e. Here we would say that h is jointly proportional to c and the square of d. So jointly proportional to c and d squared. You could also say directly proportional to the product cd squared. So it's directly proportional to the numerator. It's inversely proportional to the denominator. You could say it's jointly proportional to c and d squared, and then inversely proportional to e. So, um, and in that way, we have some terminology to build up a relationship in a formula in an equation that we can then use to solve for the constant of proportionality. If we are given some values, like in this particular case, what if we were given the value of c is 1, d is, uh, let's suppose that what if d is 1, and what if e is 1? And then we know that in this particular situation, the h will turn out to be 2. Then guess what k would be? Well, it's pretty simple. It's going to be 2, because you have 2 times 1 times over 1 is going to be 2. So, so then you could know that k is 2. Then using that information, what if I said, okay, well, what if h were 4 and so what if h were 4, and let's suppose that e was, so h is 4. What if e was 1 and c was 1? Um, and then the question is, what is d? Then what would we do? Well, we could say, okay, 4 is equal to 2 times, and then we have lots of ones, but then we have a d. So 1 times d squared all over 1. Now we can divide both sides by 2. So we have 2 is equal to d squared. So lo and behold, d is going to be the square root of 2. Now in the given situation, depending on the word problem, we might not want a negative. So we just say positive square root of 2. If we wanted a negative, I guess it could be a negative. But that's situational. Okay, so that concludes our little instruction on inversely proportional, directly proportional, and jointly proportional. Sometimes the wording varies a little bit, like it could be varies directly as, or varies inversely as, or varies jointly as, but pretty much they all mean the same thing. Thanks for watching.